Hi everyone, sorry this is kind of late. I'm actually still in study hall duty. So then also unfortunately do not have my calculator with me, but I borrowed this from somebody. It's not a normal graphing calculator, but I'll make a different video going over how to use those later as well. Okay, so in general meaning of log base b of x. So if we say log base b of x is equal to I don't want to use a and confuse people. Let's say it's equal to z, right? Then that just means b raised to the z power is equal to x, right? So an example we can use is log base 2 of 8 means what power do I raise 2 to get 8? The answer of that is 3, right? So we see that also lines up with this, right? The base to the thing, the log of the base of x is equal to is x, right? So log base 2 of 8 is 3 because 2 to the 3 is 8. So we also want to point out that 8 is just 2 cubed, right? So log base 2 of 2 cubed is 3. This 3 is just this exponent, right? Because if log base, obviously you raise 2 to the third to get 2 to the third, right? So what's happening here is that our base and the base we've chosen to write our new number in, or this is actually called the argument, but the 8 we write as 2 to the third. So now we're writing it sort of as log base b of b to a number. So I'm actually going to write as log base b of b to the x is equal to x, right? Definitionally, b to the x is b to the x, right? You would raise b to the x power to get that number. So that will always be true. Here's the example with 2, but as long as the base and it's a base raised to an exponent, that you just keep the exponent, right? So that should make us think when we have things that are, actually I don't know that I want to do that yet. But for example, if I have 3 to the x is equal to 7, then I can take log base 3 of 3 to the x and make that equal to log base 3 of 7, right? So now this is just a number, and log base 3 of 3 to the x falls under this categorization of log base b of b to the x. So that just turns into x, and x is equal to log base 3 of 7. If you actually, so that type of problem would look just like this one. A to the x is equal to 1,000. We will tackle that when we get there. So I want to leave a few for you to do as practice problems, but so let's think. 10 to the x is equal to 1,000. We can say that x is 3, right? X equals 3 because 10 cubed equals 1,000, right? So now log 1,000. If you don't remember from earlier, when we just see log without any base attached to it, that implies log base 10, right? So base 10 is your assumption if you're not told otherwise. So this is just log base 10 of 1,000, and that's equal to 3, right? 10 to the third is equal to 1,000. So in that sense, these two are parallel problems. More specifically, they are, this shows that they are inverses, right? Logarithms and exponents achieve opposite goals, right? For me to figure out the exponent there, right? What I'm actually doing is taking log base 10 of both sides, right? I'm taking log base 10 of 10 to the x, which is x, and log base 10 of 1,000, which is 3. So if you want to, try that for 3 and 4. Let's see. Actually, I'm going to ignore that one for now because it's part of the, it's part of the earlier problems in the packet. So let's look at a to the x equals 1,000. Right, this is different than some of the other cases we've seen because we're not going to get 1,000 into base 8 in a clean manner, right? So we aren't just going to make this 8 raised to something and set that something equal to x. So now this is where we go back to taking log base something, right? So in this case, I want to take log base 8 of 8 to the x, right? Because log base 8 of 8 to the x is just x, right? So now x is just log base 8 of 1,000. If you have a TI 83 or 84, you can hit the math button. Actually, I think if it's TI 84 color edition, you'll figure out if you have this or not, but if you hit the math button, which I believe is like the third, fourth, or fifth button in the leftmost column of that calculator, and within math, you scroll down to the bottom. If you see log base with base in all caps, you can choose that and then input your desired base and argument. So you could just go to log base and then hit 8 and 1,000. This is a property that, this thing I'm now about to tell you is a property that we will explain later in class at some point. But for now, for people with 83s or just using their phone calculator or something that doesn't allow you to input bases, separate plug, I believe Desmos and GeoGebra both allow you to input bases if you wanted to do your calculations there. But this is also equal to log of 1,000 divided by log of 8. So that's log base 10 in both cases. We'll actually end up finding that it's trivial what base you change it to, as long as it's the same base. But again, that's more complicated and we'll get there when we get there. Just know that on your calculator, these two are the same thing, right? So if your calculator doesn't give you the option of doing log base 8 of 1,000, you can just do log of 1,000 divided by log of 8. So let's do that here. I'm gonna take log of 1,000, which is 3, like we thought it would be, divide by log of 8, and I get so I get x is roughly equal to 3.3219, so 3.32. Great. So you see the schools? That just means it's not exact, the same way that the square root of 2 is the square root of 2 and not 1.414, right? So on a test, I'd be fine if you told me this as a final answer, the same way that with like the quadratic formula, I'm fine with you telling me 3 plus or minus the square root of 7 all over 2, right? Same thing, exact number, and decimals aren't as clean to work with. Also, if I find, actually, is there a second answer thing? Sorry, I'm getting a hang of this calculator. So if I can also now do 8 raised to the, so if I go second answer, this actually just now plugs in my previous answer for where I've told it to. It will be the same button, I think button combination and placements on the TI 83 or 84, second still up there, and answer should be the negative sign or directly to the left of enter. I'm not sure if that's different on an 83, 84, right? But now, so 8 to the 3.3 is exactly 1,000, the same way that 8 raised to the, what we had said of 3.322 is actually just really, really close, but still not exact. So again, we'll give you a good benchmark, but keeping it in this form, like this will give you a great idea of, say this is a number of years, and you find out, oh, it's about a bit more than 3 years in, right? That will give me more information than log base 8 of 1,000. But while you're doing calculations, it's okay to keep it as this and evaluate at the end so you'll have cleaner numbers to work with. Also, you know, we don't want to rely on our calculators too heavily, because if you forget a parenthesis somewhere, or like maybe you accidentally took log of 81,000, right, and you never entered a base, right? So we just want to make sure that the number we evaluate is the number that we want and not lose points over trying to use a calculator. Great, this thing would be the same thing, right? Just because these are uglier numbers doesn't mean that I still don't do log base 18 of 18 to the x, which is equal to x, which is the left side, and now the right side is just log base 18 of 435.7. So again, if you go to math, if you go to math and find a log base function on your calculator, you can just do log base 18 of that number. For those of you who can't, it's just log of 435.7 divided by log of 18. Right, so 2.102, and if I say 18 raised to the 2.102, pretty close to 435, right? So easy to check your answer, easy to make sure that it makes sense, and just a simple step, take log base this of the thing we want to get rid of to isolate the exponent. So I can let you try that one for yourself, and also 9 for yourself. This is just a more generic thing, right? Log or b to the x is equal to c. If we are still looking to isolate x, then I will take log base b of b to the x is equal to x is equal to log base b of c, right? So that's no different than what we had here, right? We had a to the x is equal to 1,000. So, and then we have log base 8 of 1,000 is what gives us the exponent x we're looking for. Great. I'll let you try that one for yourself. That's just numbers. Oh, great. So now this one, up to you if you want to write 0.03 divided by 4, right? So you can also rewrite this as 1.0075 to the 4x is equal to 2. All right, so whatever, just if you making that one number is easier for you, right? So now this is my base raised to the 4x, and I want to take log base that number. Right, so I want to take log base 1.0075 of 1.0075 to the 4x is equal to log base 1.0075 of 2. So now this is important. I just get rid of the base and have to keep the exponent of 4x, right? It doesn't just go to x, I have to keep the whole thing, is equal to, yes?
Is this for us?
Does it sound like stuff from like material from your class?
Yeah.
Yeah. Okay, great. And now that's just a value. Wow, that's a large number. Not helpful. What good are your AirPods? 92.76, right? And that's equal to 4x. And if I want to figure that out, I want to divide by 4, get x equals 23.19, or roughly that. Okay, sorry this is late, hopefully it's helpful, and I will see you guys soon.